Okay, let's take a look at problem number 1 on that surface area of pyramids worksheet. So I saved this one for now, not because it's hard in terms of finding that slant height like we had to do with problem 3, but the base of this is a little bit harder to find the area of than some of the other problems. So it's a hexagon again, which again, if you had to choose hexagon or pentagon, this is the easier of the two, but still harder than, say, a triangle or a rectangle or a square. Okay, so let's draw the net. So our base is a regular hexagon. You can tell because they've labeled everything as congruent in that base. Right, you can see all the angles are marked as congruent, all the sides are marked as congruent. Right, and then from there we've got 6 triangles that come off. And again, accuracy is tough in these problems. So really what we're just trying to do is remember what we need to find the areas of for the surface area. And if there are two things that are unequal, kind of draw them unequal. If they're equal, then just kind of know that they're equal. All right, so in order to find the surface area in this problem, we're going to have to find the area of 1 hexagon and 6 of these triangles. Okay, again, I tend to go for the easy one first just to get that out of the way. So let's take a look at these triangles. So it's telling us that the base of the triangle, let me do this one up here, the base of the triangle is 12 millimeters, and this height right here is according to the diagram, is 14 millimeters. All right, so if we're trying to find the area of one of them, it's going to be 6 times 1/2 base times height. This 1/2 and the 6 will cancel out and we'll get 3 times the base, which is 12, and the height, which is 14. All right, 3 times 12 is 36, and 36 times 14 is going to give us 504. And so the area of those 6 triangular sides that come up here and meet at that point is 504 square millimeters. So let's take a look at the hexagon. So if you remember from last week when we did these, the first thing we had to do, and you just might want to memorize some of the interior angles, but if not, I'm going to do it from scratch because if you forget on the test, I want you to remember how to do that instead of, try to recall it and not be able to recall. So pick a vertex and from there connect it to every other non-adjacent vertex. So that is adjacent because there's a line segment that connects them already. This is adjacent because they're connected. So we're going to connect it to this one, and this one. Our little kitty friend is back. Okay, so that makes 4 triangles, each whose interior angles add up to 180. So 4 times 180 is 720. So the sum of the interior angles in this regular hexagon is 720. Regular or not, it's still 720. The regular part ensures that when we come down here and draw it again, that each of them is the same measurement. So in order to find that single angle measurement here, we're going to do the 720 and split it up equally between the 6 angles that we have. So we're going to end up with 120 degrees for each of these angles right here. Right, which means that when we take and we draw the center right here and draw 6 triangles from that central point, we actually end up splitting this 120 degree angle into 2, and they're each 60. So let me draw that again. That's just this triangle. So 60, 60, and this will also be 60. And then we split it down the center, and we make 2 triangles that look like this. All right, so 30, 60, 90, one of our special right triangles. We know that this is, this side down here is 12. We were told that in the diagram up here. So then when we come back to this triangle right here, we can say, well, then that's 6. We also know that this is equilateral. So if this is 12, this also has to be 12. We're not surprised by that though, because again, remember in a 30, 60, 90 triangle, the side opposite the 30 is the x. The hypotenuse is 2x. So if x is 6, then 2x should be 12. And then this side opposite the 60 is x root 3, which is going to give us 6 root 3, which is the height here of this triangle. Okay, so then let's go through and figure out the area. So we could, as we did last week, find the area of this and double it. Let's do that, but then I'll also tell you how you can just do it right from here. So we do the area of this triangle is going to be 1/2 the base, which is 6, times the height, which is 6 root 3. So area is 1/2 of 36 root 3. And let's do that in the calculator. And again, I'm going to keep using that. I'm not going to round it just yet. So I get that this is 31.17. And again, I'm going to say that the area is approximately 31.17, but I'm just actually 0.18, sorry, but I'm going to keep using the value that's in my calculator instead of rounding it right there. All right, so then that's the area of this. So to find the area of this, I'm going to double it. So on my calculator, I'm just going to say times 2, and it will automatically double that thing that's got like 8 decimal places after it. All right, so the area of this is approximately 62.35. And then the area of this is going to be 6 times that. All right, 1 for each of the triangles that we formed in there. So let me put that back up in our formula right here. So the area of this, we're going to do 62.35, or it's saved in my calculator, times 6. And we get, I'll put it down here, 374.1212. All right, and then add 504 to that. Whoops, I did times 504. And we get, oh my goodness, I'm his favorite person, in case you couldn't tell. All right, it's 878.12. And then it's millimeters, and since we're talking about surface area, it's millimeters squared. Okay, so I'm going to ask you, after you're finished watching the ones for problems 1 and 9, to do problem 2 on your own. So if you need to come back and watch this video again, please do.